This video is going to talk about Pythagorean theorem and its converse. First, with the warm-up, we're reminding ourselves that in order for three numbers to create a triangle, the sum of two has to be greater than the third. In our classes, we just, to keep it consistent, we just say our small plus the medium have to be greater than the large. That way you're not trying to decide which sides to add, etc. It's just easier this way. So the first example, if we take the two smallest, the 3 plus the 4, it has to be greater than the largest of 5. And so this ends up being 7 is greater than 5, which is true, so this forms a triangle. The other one, if we take the two smallest, the 10 plus the 12, it has to be greater than the third of 24. And we add these, we're going to find out this is not going to be greater. The sum is not greater, so this ends up not being a triangle. Now with Pythagorean theorem and its converse, we're looking at what Pythagorean theorem is something that in Texas we've been talking about since 7th, 8th grade. This is saying, hey, this is a right triangle, therefore a squared plus b squared equals c squared. In this case, with your right triangle, we need to remember that the hypotenuse, which is labeled as c, is always the longest side. Not only is it always the longest side, but it is always across from the right angle. The converse, instead of saying this is a right triangle, use a squared plus b squared equals c squared. The converse is saying, hey, here are three sides. Does c squared equal a squared plus b squared? So instead of saying this is a right triangle, solve, now we're going to say, here are your numbers, is it a right triangle? So let's go ahead and take a look at determining if these two are going to be right triangles. First things first, identify which is the largest number. Identifying the largest number is going to tell you what we're plugging into C. Because this is the largest number, it's the longest side. So using the c squared equals a squared plus b squared, this is also going to help us, this format's going to help us on our next page. We're going to go ahead and plug in 65 for c squared, 65 squared. A and b, as a reminder, doesn't matter which one is which, so we'll plug in 16 squared plus 63 squared. We'll go ahead and square our numbers. 65 squared, don't expect you to have it memorized, is 4,225. 16 squared, good idea to have this one memorized, 256. Plus your 63 squared will be 3,969. We'll go ahead and bring down the 4,225. When we add the two smaller sides squared, we're going to wind up with 4,225. So this we can confirm this is going to be a right triangle. On number 2, we take a look. The largest number is going to be 25. So this is what we're going to plug in for C. So we would have with our c squared equals a squared plus b squared. We'll plug in 25 squared for C. And again, A and B, it does not matter which one is A and which one is B. Please make sure you put the squared on there or you will have the incorrect answer. So 25 squared is going to give you 625. I always recommend my students have up to 25 squared memorized. 10 squared you should definitely have memorized as 100. 24 squared is going to end up being 576. When we compare that sum to 625, we're going to find out the sum is going to be 676. These are not equal, therefore this is not a right triangle. So now let's take a look at Pythagorean triples real quick. You do not have to have these memorized in my class. It's always a good idea to have them memorized so you can immediately look at what's going on. Do we have a right triangle immediately without having to plug in? What I do want to note to begin with, 3 of the most common and most easily seen triples are going to be your sides of 3, 4, and 5. Another one is 5, 12, 13. Another is 24, and 25. We're going to take a look at some of these down here. And then the 5, 12, 13, and the 7, 24, 25, and we're going to see how this works out, and then we'll talk about that 3, 4, 5 in a minute. So with these numbers, let's go ahead and identify our largest number. 13, which will be C. So we're going to test these out. 13 squared equals our two smaller sides squared. 13 squared is 169. 5 squared will be 25. 12 squared will be 144. When we add the 25 plus the 144, we end up with 169, showing this is one of our triples. Next, we're going to take a look at, I'm going to go ahead and skip over to C, because this is one that's listed up here, and we'll see that in the making. 25 being the largest number, we'll set 25 squared equal to 7 squared plus 24 squared. We square our numbers. Your 25 squared will be 625. 7 squared is 49, and the 24 squared is 576. Bring down that 625. When we add 49 plus 576, we're going to see 625. Now with B, we're going to write kind of small and off to the side because we're going to write something else over here. Let's go ahead and do the same thing. Let's take this largest number, 15, squared equals 9 squared plus 12 squared. 15 squared is going to give us 225. 9 squared is 81. 12 squared is 144. When we add the 81 plus the 144, we're going to get 225. B is what we call a multiple of a triple. What that means is this is a multiple of the 3, 4, 5 triple. Let's see how. If we write down our 3, 4, 5 triple, each one of these is multiplied by the same, we just got done with scale factor, the same number, the same scale factor to get the 9, 12, and 15. Each one of these is multiplied by 3, and that is how we get the 9, 12, 15. So we have this multiple of the triple. So that's a good idea to recognize those as well. Again, the 3, 4, 5 is the most easiest to see. Now, the converse of the Pythagorean theorem is also going to allow us to classify our triangles not only as, hey, are they right triangles, but we can use the Pythagorean inequality theorems to see our non-right triangles are acute and are obtuse based on these inequality statements. So the first one is stating that c squared equals a squared plus b squared. Well, we just got done with that. This means the triangle is right. The way I state this and the way I help students remember, it's very important that c squared goes first. If c squared is greater than a squared plus b squared, then the triangle is obtuse. If c squared is bigger than, greater than, then your angle is going to be bigger than, greater than 90 degrees. Your right triangle, so it'll be obtuse. And then if c squared is less than a squared plus b squared, if c squared is less than, is smaller than, then your angle is going to be smaller than 90 degrees, giving you an acute triangle. So in this table here that we're going to look at, we're going to take these side lengths. Before you can state what kind of triangle it is, you have to identify if it is even a triangle to begin with. Because if it's not a triangle to begin with, like our warm-up, we looked at adding the two sides to be greater than the largest. If that doesn't happen, it's not a triangle, then we don't do anything else. We're done. We just say, no, it's not a triangle and move on. Okay? So what we're going to do is first take a look at your small plus medium being greater than your large. And then we'll go through this table. I'm going to go one at a time. So here with your 5, 12, 13, we're looking at the two smaller, 5 plus 12 being greater than 13. 5 plus 12 is going to be 17. This is going to be a triangle. So now we move on. What we're going to do is we're going to square the longest side. The longest side is 13. So we're going to take 13 squared and find it as 169. Next, we're going to take the sum of the squares of the two shorter sides. All we're doing here is we're doing what's on the left side of the inequality or equal sign. Then now we're going to do the right side. We're taking a squared plus b squared. So we'll take the other two sides, 5 squared plus 12 squared. We'll find out this is 25 plus 144. This will give us 169. Now we can look at these two and say, is the column of the square of the longest side, is it less than, greater than, or equal to the sum? And we're going to compare these, seeing we're going to end up being equal to. And that's why it's set up in this way, the longest side squared column first, and then the sum of the shorter two sides squared. So now we can look at, okay, if it's equal to, we have a right triangle. So we're going to continue through doing the same thing. Over here, the next one, we have 6, 6, and 12. So first things first, take your small and medium, compare it to your largest. We're going to find out that these are equal. Cannot be equal. Right now, we have no, this is not a triangle. So you know what you do for the rest of the columns? Nothing. Nothing. If it is not a triangle, we're done. You say not a triangle, move on. Now we take a look at the next one. We'll take 5 plus 12 and compare it to the other 12. This will be 17 is greater than 12. So yes, we do have a triangle. Over here, next column, let's take the square of the longest side. Well, there's two different 12s. That's all right. We'll just take one of them. Take 12 squared to get 144. Now we take the other two, the 5 and the other 12. 5 squared plus 12 squared. Because it's 25 plus 144, giving us 169. Now we compare the 144 and the 169. Is 144 greater than, less than, or equal to? 144 is less than. So this is your less than sign, because it's going to eat the 169. So because it is less than the sum, the angle is less than 90 degrees. Next, go ahead, take our smaller two sides, 5 plus 12, compare it to the 15. We end up with 17 is greater than 15. All right, we have a triangle. Let's move forward. Largest side, 15 squared. We get 225. We're going to compare this in a minute. Take the other two, the 5 squared and the 12 squared. No, we already have it up here. Make sure you have your work, though. Your 5 squared plus your 12 squared. 25 plus 144. This will equal 169. Compare the 225 with the 169. 225 will be greater than 169, so the angle is greater than 90, giving you an obtuse triangle. I encourage you to pause it and go ahead and work through the other ones the exact same fashion. If you're a little nervous too, that's fine. Let's take a look at this next one. Okay, 5 plus 6. See if it's greater than 12. 5 plus 6 is 11. This is not going to be, this is going to end up being less than 12. So this is not a triangle. So again, no triangle, say no, and move on. Next, we'll take 6 plus 12, compare it to 13. We end up with 18 is greater than 13. So we do have a triangle. The largest side, 13. 13 squared is 169. We will now compare this to 6 squared plus 12 squared. 36 plus 144. This will end up being 180. 169 is less than the 180, so the angle in the triangle is less than 90. Acute. 6, 12, and 15. We end up with 6 plus 12, compare it to the largest side. We end up with 18 is greater than 15, so we do have a triangle. Longest side, 15 squared, is going to give us 225. We will compare this to the two smaller sides, 6 squared plus 100, I'm writing down what 12 squared is, plus 12 squared, 36 plus 144, we have that just above, 180. We see that 225 is greater than 180. The angle in the triangle is greater than 90, giving you an obtuse triangle. Now I do want to note how we usually write this when showing our work. We don't have the actual, we don't have the table. So all you have to do here, if I take this example up here, the very, very last one, we can set it up as 15 squared equals 6 squared plus 12 squared, and then go through, again, I'm showing you how to do your work in our classes at Katy High School. You end up with 225 equal to 36 plus 144. And that last one we take a look, leave that blank, we wind up seeing that we have 225 is greater than 180. So this is how you can show your work, or if you just want to leave, you know, the equal sign as a blank. I used to teach my students how to do that when adding, but this is how we look at it. That way we can see that c squared equals a squared plus b squared. Now we're going to look at two word problems. So we're going to go back to just Pythagorean theorem, we write triangles, etc., and look at word problems and how to set these up, making sure that we understand different things and different terms and what they mean. The first one is going to be to help support a flagpole. 50-foot long tether is tied to a pole at the point 40 feet above the ground. The tether is pulled taut, meaning very, very tight. Okay, there's no slacking in it, very, very tight, and tied to an anchor in the ground. How far away from the base of the pole is the anchor? A lot of words we need to understand that will continue on through different word problems. First, we have a flagpole. Let's go ahead and draw in our flagpole. Your flagpole is always going to be vertical. And if you don't want to draw like an actual legit flagpole, that's fine. Just know that that's going to be the flagpole. It's going to have a 50-foot long tether tied to the pole to a point 40 feet above the ground. So let's go ahead and draw. The tether's going to go like this. All right? Let's go ahead and see that. Or it might say a rope or a string tied from the top to the ground. This is what it is. Now, we know that the ground is right here horizontal. And the flag and the ground will always form a 90-degree angle unless the wind really blew the pole over, but we always assume it's going to be a 90-degree angle where the flag and the ground meet. So this tether is 50 feet long. So that means this tether, 50 foot, it's tied to the pole at a point, so it's tied to the pole where it's tied to the pole, 40 feet above the ground, which means that tie is 40 feet above. Now, it might be down here, who knows? It didn't say it was at the top, but where it is tied to the pole is above the ground, giving you the 40 feet is right here. We want to know how far away the base, okay, here's the anchor, by the way. The anchor is what's on the ground, tying it, okay, to the ground. We want to know how far away from the base of the pole, right here where it meets the ground, how far away that base of the pole is to that anchor. So this is what we're looking for. So looking here, we need to remember that C is always going to be across from that 90-degree angle, so 50 is going to be our C. Using our Pythagorean theorem of a squared plus b squared equals c squared, I'm just going to use x to represent the missing part here. I always like to put the x first when it's one of the legs. So I'm going to put on here x squared plus the other leg, 40 squared, is equal to the hypotenuse, 50 squared. The rules with the Pythagorean theorem are always to square the two numbers you have. Then you'll either add or subtract, depending on what you're looking for, and then you take the square root. So here we're going to go ahead and square the two numbers to get 1,600 and 2,500. Then we're going to subtract the 1,600. So in this case, we square the numbers, now we subtract. We get x squared is going to equal 900. Then that last step in Pythagorean theorem is always to take that square root. X is going to wind up being 30 feet. I also want to show you something. If you noticed that this is a multiple of a triple. And if you notice that in my class, if you know it's a triple, write the word triple and move on. Okay? I will allow that. This is a multiple of the 3, 4, 5 triple. And how we know is because if we take that 3, that 4, and that 5, the multiple is, or the scale factor rather, is going to be 10. We multiply all of these by 10, we get 30, 40, and 50. So you could answer it straight up, well, that's a 40 and 50. I know the other one's going to be a multiple of 3. Multiply 4 times 10, 5 times 10, so I'm going to multiply 3 times 10 to get that. Please don't concentrate too much on the triples if it confuses you. Now, B, we have a 20-foot ramp is used on a loading dock out of a facility. If the base of the ramp is placed 8 feet from the base of the dock, how high is the loading dock? We are going to leave our answer in the simplest radical form. We've learned how to simplify radicals. So let's go ahead and start off by drawing. Ramps are always going to be your hypotenuse. It's going to be the diagonal. So here's your ramp. The base of this ramp, right here, where it touches the ground, let's go ahead and draw in the ground, okay? The base of the ramp, and note that's what this is going to be placed 8 feet from the base of the dock. Now, your dock is what that ramp is leaning up against. So here's your dock. So this will be 8 feet. Here is the base of the dock. And it is 8 feet from that. We are seeing here that we had the ramp, what I forgot to write on here, but it's okay, we can go back. It is a 20-foot ramp, meaning right here the ramp is 20 feet. We want to know how high up is this loading dock. So this is what we are looking for here, remembering that this dock and the ground are going to form that 90-degree angle. So again, we have C. We're going to be looking for one of our legs. So we'll have, again, our missing leg of x squared plus the other leg of 8 squared, all equal to, C is always across from the 90-degree angle, 20 squared. I will tell you right now, this will not be a triple. We'll subtract that 64 from both sides to get x squared equals 336. That last step of taking the square root, we need to go to the side and simplify. If you've never seen my videos with the radicals, I simplify using a division tower building upward, so all my prime numbers stay together. If you do the factoring, please do that. You can look at my simplifying radicals video to see how exactly this works out, but I'm going to go pretty quickly here. I'm going to take my 336 and start dividing by the smallest possible prime number. We can divide by 2, we get 168. Divide by 2 again, 84. We keep dividing by 2 until we can't anymore. We're going to wind up with 42. Divide by 2 again, we get 21. Now I can no longer divide by 2. I need to move to the next prime number, 3. I can divide it by 3, and I'm going to get 7. Once we have that prime number at the top, we are done. So we're going to go ahead and take a look at our radical house. Our partners, we're going to place outside. We have a 2 there. We have another 2 here. And the 3 and the 7 are lonely. They don't have a partner. They have to stay inside. When we do our multiplication, we find out that the answer is 4 square root of 21.